Hi. Okay, so we should be on to question. Okay, I'll try to finish these four questions as soon as possible. Okay, so from Form 5 Chapter 1. Okay, so I know many of you struggling this chapter. Okay, so I try to explain it clearly. Okay, so um, whenever you see there are two different metal electrodes, okay, you already know this is vortex cell. You only got two types of cell. Number one is electrolytic cell. Number two is vortex cell. Okay. So meaning of redox reaction. This one they frequently ask in essay question if they come out in Form 5 Chapter 1. So you can write down. Okay. It's a chemical reaction where oxidation and reduction occur simultaneously, or you can say happening at the same time. Okay. Okay, yang berlaku secara serentak. Okay. I know it's 1 mark. Okay, 1 mark for meaning of redox reaction. But it's not that hard because just remember this chapter is redox. Redox means you got these two happening at the same time. If you got any question, you can ask, huh? Okay. And then we analyze. Okay. So based on these two, okay, you got zinc and copper electrodes. So you have to know which one, always have to know which one is anode, which one is cathode. Okay. So just remember when you see E naught value is more negative, means it's anode. Yeah. E naught value is more negative, or you can say which one is the one that is more electropositive. That is the negative terminal. Or you can say the anode. Okay, anode. So it means zinc is anode negative terminal. Anode negative terminal for potassium. And then the other one, which is more positive, that one is cathode. Okay. That one is cathode. So, like example, copper here, the E naught value is more positive, that's why it's cathode positive. Okay. Electron flow from anode to cathode. Okay. And then we analyze, okay, what happened to anode, what happened to cathode. Is it atom turn to ion or ion turn to atom? So this one, zinc dissolve, zinc atom dissolve become zinc ion. At the same time, copper 2 ion, terbalik because anode will become inner. The electron will dissolve into solution and become inner. Meanwhile, cathode, the whole electrode become thicker. Okay, because you know, anode undergo oxidation. Anode undergo oxidation. A bit laggy. Yeah, I have to use my data because don't know why my Wi-Fi down already. Okay, so oxidation, donate electron. Cathode means reduction, receive electron. So it's like copper to ion will receive 2 electrons to form copper atom, copper metal. That's why you can say the electrode become thicker, or you can say the brown solid deposited because copper is brown color. Okay. After you analyze, you can answer many questions. Okay. So which one is negative? Okay. So you can just answer. Copper is positive, zinc is, sorry, I wrote wrongly already. The answer got be wrong. So sorry. So negative terminal is copper. Is it copper? Am I terbalik? I think I'm terbalik. No, I terbalik already. Okay, I terbalik. Okay. I think the answer is, yeah. Okay. So the negative terminal is zinc. So sorry. Later I try to correct it and send. Later I correct the PDF and send it again. Okay. Maybe for those who like not attending the class. Yeah. So terminal negative. Yeah. Okay, the half equation and the ionic equation. Okay, so the oxidation one is N. So N naught means the Zn donate 2 electrons become Zn2 plus. Okay, then cathode undergo reduction. Okay, which Cu2 plus receive 2 electrons become Cu. So can I? Cathode can I? Then the ionic equation. The ionic equation is just balance the number of electrons, which you already balanced from the two half equations. Okay, then you don't need to write the electron. Then you just write the leftover. So Zn Cu plus L becomes Zn2 plus Cu. Okay, okay. So you know how to write half equation and the ionic equation, no problem. Just remember the oxidation one donate electron, the reduction one receive electron. Cell notation to write. Okay, cell notation. Okay, look carefully what they give. Okay, so but here they didn't give any concentration. If they give, let's say, if they give like 1.0 mole per m cube, then you have to include in the cell notation. But since no, then you just write the physical state enough. Okay, so I write. So okay, Zn solid. You write the anode part first, then you write the cathode part. So the anode part is Zn solid, one slash becomes Zn2 plus aqueous. Aqueous means aqueous, okay, in the water. And then the cathode one, Cu2 plus aqueous, become Cu, solid. That's it. Okay. So in Malay one is like this. So same thing, you just change to per joule and change to AK. The other thing are same. Yeah. Calculate the E naught cell. The place. Okay. In place. SEL. In English is CEL. The formula is okay, E cathode minus E anode. Okay, the voltage E cathode minus E anode. In Malay is cathode like this. You just change yourself. And then the cathode here is positive 0.34. Then the anode is negative 0.76. So you use positive 0.34, okay, minus negative 0.76. Then you will get positive 1.10 volt. Okay. You already gotten a lot of marks. Okay. Okay. So see now, just if you notice, right, this is the I would say like the most common, most normal for Excel. Okay. So, but if they want to, because if you see right, this one they dipped 2 electrodes into the same solution. Okay, but they're not even the same, I think. Okay, here they already split with the porous pot. Okay, so Either they can split with porous both. Okay, because like one is zinc dissolved in zinc sulfate, copper dissolved in copper sulfate. Okay, or you can separate like this. Okay, so but this one is even more I would say not complicated, but more cells need to analyze because here already got two cells. Okay, just now only got one cell. Okay, here since you got two cells already, then you have to analyze which one is volatile cell, which one is electrolytic cell. So the moment you see you got two different metal electrodes like zinc and copper, you know this is volatile cell. Because cell B can't be volatile cell because you got two same metal electrodes. Definitely cannot. This one is supposed to be electrolytic cell. Okay. So we analyze first, then we answer the questions. Okay. So again, just now we already analyzed, right? For this cell, we already analyzed that. Oh, you know, zinc is anode negative, copper is cathode positive. I already told, right? I already told you because zinc has more negative inert value. Copper has more positive inert value. Okay. And also you have to know for cell B, which one is anode, which one is cathode. But remember, there's one rule you have to know. Electron always flow from anode to cathode. Always from anode to cathode. So it means electron goes like this, huh? Okay, from here come out until the right side of cell B. Then the right electrode of cell B is cathode. And then remember, there's one rule also for volatile cell and electrolytic cell. Volatile cell is A minus C plus. Okay, A minus C plus. For electrolytic cell, A plus C minus. So it means if volatile cell, the cathode is positive, then electrolytic cell, the cathode is negative. Okay, and then anode is positive in this case. The other side. Settle? Now we just look at what chemical to what chemical. Okay, just now we already analyzed this. Zn dissolved becomes Zn2 plus. Cu2 plus become a lot of copper coming up. A lot of brown solid form. This one you already analyzed. Okay, and because anode undergo oxidation, cathode undergo reduction. You already know, right? Same thing to apply here. Anode we also undergo oxidation, donate electron. Okay, cathode also undergo reduction, receive electrons. Okay, and then for volatile cell, we've already done analysis now, but electrolytic cell, the thing is, you always have to see what is the electrolyte used and what is the ion inside. Okay, to determine which ion undergo oxidation, or particularly sometimes can be atom, okay, can be molecule. So that is, you got copper 2 sulfate solution. Okay, so it means what? It means you got 4 ions, remember? Not only writing 2 ions, 4 ions, which is copper 2 ion, sulfate ion, hydrogen ion, hydroxide ion. Because you got water. The salt dissolved into water. So water got 2 ions, which is H plus and OH minus. Okay? So electrolytes always have to analyze this. And then you have to know which one goes to anode, which one goes to cathode. So remember, positive ion known as cat ions. Cat ions goes to cathode. Negative ion known as anion. Anion goes to anode. Second, no problem. And then analyze which one undergo oxidation, which one undergo reduction. We analyze the cathode first. Okay. So which one? Okay. What is the factor? Cathode only got one. Just remember, okay? Cathode only got one, which is E naught value more positive. Normally, if you see E naught value more positive means the bottom one. Based on the reactivity of metal, the bottom metal. Okay. So which is like the less reactive metal. Okay. So which one? Now, I can tell you now. Okay. So for H plus is 0.00 volt. Okay. H plus is in the middle. Copper one is positive 0.34 volt. So which one do you choose? Based on this factor. So you choose copper undergo reduction. So copper will undergo reduction by receiving two electrons. I mean copper to ion. Copper to ion receive two electrons, become copper metal. Okay. So it means, isn't it here got a lot of the observation is the brown solid depositor. Same thing happened to this cathode in cell A. Okay, Cu2 plus becomes Cu. Same thing. Okay. But how about anode? Anode always have three factors. What is the first factor? Type of electron use. Okay, type of electron use. Okay, whether they have active electrode or not. Okay, like copper and silver. You wait me a second. Okay, and then number two is you always see the concentration of the halide ions, which is Cr minus, Br minus, I minus, whether they are more than or equal to 0.5 mole per dm cube. Or if they say concentrated, also can. Number three, E naught value more negative. Later, if you see more of the electrolytic cell question, you can apply to this. If they ask you to choose which ion undergo oxidation at anode. Okay, so you already know, you check what electrode they use. Do they have copper? Yes. So it means you don't choose the ion because you got the first factor secure in this case. Okay, in this case, you got first factor secure. So copper is the one undergo oxidation, become copper to ion. In this cell, okay, in cell B. Okay, so settle. It means this oxidation is the electrode become thinner. Okay, settle because the copper electrode dissolve. If you see copper or silver, important. Okay, so then they ask you to write what is the product form, what is the observation, and what is the half equation. Okay, so product form in cell A, you see, I write the half equation first. Cu becomes Cu2 plus 1. No, sorry. This one is cell A, sorry. Cell A is what? Cell A is vortex cell. Sorry. So this one is Zn, sorry. So it's Zn becomes Zn2 plus. Because they ask you to compare cell A and cell B at anode. Okay. Both only anode. Both only anode. But they ask you to compare product form, observation, half equation. So you can say cell A is zinc ion. Okay. Cell B is Cu2 becomes Cu2 plus, donate two electrons, which is copper to ion produced. Observation, both become thinner. It's just that this one is zinc electrode become thinner. This one is copper electrode become thinner. That's it. Okay. Okay. And then now for the long question, I won't let you copy now because I'm a bit of a rush. Okay. So later I'll send answer in group. I send answer in group, and then you can copy later. But I explain how you all get answer. Okay. So unless you're copy very fast. Okay. So okay. So this one I explain a bit. Okay. This one is Farida's house. Don't copy first. Don't copy first. Okay. Later you got time to copy. Okay, Farida's house is located at seaside. Okay, she has a problem when her steel doorknob always need to be replaced. Okay, it means need to replace due to rusting that occur faster than at the area. Okay, normal class talk about this because we're nearby seaside. Okay, because seaside means contain seawater ma. Seawater contain a lot of salt. Okay, salt water can increase the rate of rusting. Okay, so as Farida's friend suggests a way to solve the problem by using electrolysis concept. It means this one you have to literally just create your own procedure, okay, to help him, or I mean help her in this case, to get a better doorknob, better quality doorknob. Okay, so that the doorknob won't easily get rusted later on. Okay, so it means electrolysis concept means remember this concept. If you see, I draw for you straight away. Remember one of the electronic cell? Okay, you got two or three, right? One of them is extraction of aluminum oxide. Okay, so the other one is a. Remember, you got impure copper and pure copper, impure metal, pure metal. Okay, then you have to make the impure metal become pure. This one is called purification metal. The one is also electronic cell. This one the same. If you see, there's an iron spoon here. Then they have to use a sacrificial metal like copper or silver to protect the iron spoon. This one is the same thing. Okay. So, but this one is not, it's not iron spoon, but they changed to doorknob. But same thing. Okay. So you still have to use two electrodes. I mean not two electrodes, but one electrode, and you connect the other one, you connect doorknobs. Doorknob. I'm not sure how to draw doorknob, but okay, but they did ask you to draw. Okay. So don't worry. I'll show you. Okay, so agak like this. Okay, agak like this. Okay, you have to connect the positive terminal to the sacrificial metal. You have to connect the negative terminal of battery to the doorknob. Okay, because electrolytic cell, I told you just now, anode is positive, cathode is negative. So it means you want to sacrifice metal, then you have to connect to positive terminal. So that, like example, they use copper, let's say. Then copper will dissolve, become copper to ion. Then at cathode, the copper to ion become copper. That's why the copper we put around the doorknob so that the doorknob can be protected from rusting. Okay, it's just like a painting. Same thing here, you use copper to protect, to cover the whole, to wrap up the whole doorknob, so that the doorknob won't have a chance to interact with water or oxygen. Okay, so yeah. First, because they already say the doorknob is dirty, right? So you can use, sandpaper to clean up the copper electrode and the doorknob. Okay. Doesn't matter, even the new doorknob, okay, you can use sandpaper to scrub a little bit, to rub a little bit. Okay. This is the first step. Okay. And then remember you have to mention three things. The most important thing, of course, should be the electrolyte and the anode and the cathode, right? So we have to mention, or you have to use how many volume, what is the concentration of copper to sulfate solution if you are using copper. Yeah, you're using copper. Okay, you can use silver, nothing wrong. Silver is accepted, nothing wrong. But because silver is a little bit more expensive, so that's why they prefer copper normally. Copper is a bit cheaper. Okay, so you can use copper to sulfate solution, and then you let the copper as anode. Okay, the copper electrode. Sometimes exam also they can ask you to draw. So just in mind. Even I know you might draw a very ugly doorknob. Don't worry. Okay, but you just label this enough already. Okay. Then you can label this one doorknob. Connected to cathode. Okay, still not. Okay. Then you mention connect to battery, connect to wire. Immerse first. Immerse these two things into the solution. Okay. And then connect with connecting wire. You connect these two things with wire, and along with battery. Uh, that's why I say, Form 5 Chapter 1 can come out anything. Okay, so this is one of them. They can come out procedure. Okay. Connect copper electrodes and steel knot with batteries by using connecting wire. Okay, and last, just leave it open for for 1 hour lah. Okay, with low current for an hour, and you rotate. Okay, you slowly rotate lah, the steel knot. Okay, you rotate so that you rotate it. It's better because later on it won't be like, let's say this one is a bottle. Okay, this one is not doorknob. So later on you won't be like this side got a lot of copper, very thick. Then this side got no copper. If you rotate, then you'll be even. Okay, the copper is spread evenly. So this one is the 6 steps. Okay, I give you like 1 minute to copy. I move on to question 26 in 1 minute. Or you can switch also can. But later I send an answer. Homogeneous. No need to use homogeneous. Just say like evenly. A little bit of same meaning, but yeah, that one is more like liquid, right? But anyway. Okay. So you look at question 26. The other chapters, good luck, okay, because don't have much time to do. Okay. Like I didn't do much about Form 4 Chapter 7. 428. So good luck. Okay. Yeah. I can't do everything because time limited. Okay. Because as I said, every chapter come out, right? So like, yeah, good luck. Okay, so question 36. This alone take a lot of time. Okay, so analyze again lah. Okay, you already know lah. If you see battery, this is electrolytic cell. If you see you got battery, if you see you got like two same thing, right? Carbon, carbon electrode. So you already know this is electrolytic cell. And always mention long side of battery is positive terminal, shorter side is negative. And I mentioned just now, anode is positive, cathode is negative for electrolytic cell. Voltage cell terbalik, anode negative, cathode positive. And then again, we have to use this information, important, okay? The electrolyte inside. They use sodium chloride solution. So once again, we analyze which one is anode, which one is, which ion. So you got Na plus Cl minus solution, H plus OH minus. Unless you see like molten then no water. But normally if you see solution means got water. So positive ion go to cathode, negative ion go to anode. Okay. Can. This part can. Am I too fast? No. If you say too fast, you can ask. And then cathode, E not value more. Which one E not value more negative? Okay. So like example sodium. Sodium obviously is very negative. No need to see it. Okay. You know sodium is very negative. The only thing that is more positive than H plus in our syllabus. Okay. Normally it's copper and silver only. Normally these two only. Normally it can be either copper or silver. Copper ion or silver ion. Other than the top one, if you see K plus, Na plus, doesn't matter. Okay, Li plus, Mg2 plus, L3 plus, Zn2 plus, Pb2 plus, Sn2 plus. What else got? Yeah, that's it. Okay, Fe2 plus doesn't matter. Okay, all these are negative, that more negative than H plus. So you already know to see. Okay, so the answer should be H plus already. Then undergo reduction. Undergo reduction by receiving electrons, become hydrogen gas. That's why I tell you is colorless gas here is hydrogen gas. Okay, you already can analyze. Okay, this one very simple. Okay, you use the same concept. Do you have active electrode? No. Okay, do you have copper and silver? No. Okay, so you can use the first one. Second one, do you have Cl minus, P minus, I minus? Yes, you have Cl minus. Is it more than 0.5? Yes. The concentration is more than 0.5. So, Cl minus undergo oxidation, become Cl2. Okay. So, that's why you got greenish yellow gas, which is chlorine gas. Greenish yellow gas is chlorine gas. Okay. So, simple. Factor X, E not value more positive. Okay. But you don't need to even say positive. Okay. Unless they ask you to explain. This one, if you just say state the factor, just say E not value. Okay. Electron Y is concentration of solution. Okay. You write down this one first. I explain to you. Write down this first. Sorry. Okay. So the question they will ask you, okay, include the following explanation explain the difference. Okay, so they have to explain electron X and Y, list the ion that produce X and Y. I mean, attracted to anode or cathode. Okay, so we can just sit down. Okay, and then name of the ion selectively discharged at each electrode. So you can say hydrogen ion and chloride ion. Sometimes if exam didn't give you table, you can draw also. Normally, if you see like differences comparing, you can draw a table to compare actually. Nothing wrong. Okay. So only if compare or you say explain the difference. You got two sides. Okay. Or you can write in sentence, of course you can. Okay, but yeah. So you got H plus, you choose H plus and Cl minus. Okay. And then 2 marks, 2 marks, 2 marks, 2 marks. Reason why you choose, why you select this ion. For cathode, you say E naught value of H plus here. E naught value of hydrogen ion is more positive than E naught value of Na plus. Okay. And then for the other one is concentration of chloride ion is higher than hydroxide ion in the electrolyte. Yes, this is how I explain. If here is copper, then if here is copper, they will say, oh, copper is an active electrode. Like that. So copper anode ionizes to form copper 2 ion. Example. Can half equation H plus receive electron become H2 balancing 2 hydrogen, so times 2 for H plus, 2 positive, electron also got 2. This one is Cl minus, right? You choose Cl minus, right? Cl minus will become chlorine, donate electron. Then you got 2 Cl, Cl minus times 2, 2 negative, the electron also times 2. Okay? So you got 8 marks already. If you got a question to ask, can ask. Okay, so I don't know what you don't know. Okay. Then, okay, this one. Arrange. Okay. Arrange the atoms and ions in table one in an ascending order. Ascending order of the strength of oxidizing agent and reducing agent. So if you see the question, okay, and they give you a lot of E naught value, the first thing you have to do is you have to arrange it properly. Okay, so how do we arrange? So you have to arrange from most negative to most positive. Because if you see, they give you like a bit messy. Okay. So you have to arrange like this. Oh, first one. Alright, again. It's better for you to see. Okay. Or Mg2 plus become Mg negative 2.38 volts. Okay. Then you got second one is zinc. Negative 0.76 volt. And third one, P2 plus. Fourth, Q plus. So I arrange it again. Ascending means strength means either is weaker or stronger. So here, ascending means from weakest to strongest. Weakest to strongest. Weak to strong. Okay, so remember, which one is oxidizing agent? All these are in reduction form. Remember, if this thing, all this receiving electron means all these are undergo reduction. So you already know lah. Okay, the left side means oxidizing agent. Oxidizing agent undergo reduction. Can I? Right side is reducing agent. Then you know that. How do we arrange? Weak to strong. Left side. Right side just the balik direction. Weak, strong, strong, weak. The left side is top to bottom. The right side is bottom to top. Okay, so I write the order is Mg2 plus Zn2 plus P2 plus Q plus. This is OA. OA. RA is QP ZnMg. Sorry. Yeah. QP ZnMg. So I got 2 marks. Suggest metal P and Q. So if you see E not value positive, only got 2 1. Because you know H plus, the one is 0.001. The bottom only got 2. The Cu1 and the Ag1. The Cu1 is 0.34 volts. The silver one is positive 0.8 volts. So the answer is copper and silver. P is copper, Q is silver. Move on. They ask you, table 10.2 shows the reactance, okay, of 2 sides of displacement reaction of metal. Okay, to see whether they got reaction or not. Okay, identify whether the reaction will occur or not for set 1 and set 2. Explain your answer. So based on 1, okay. Based on here, okay, you compare which one is weak, which one is strong. Remember the rule, only if correction, only strong oxidizing agent and strong reducing agent combine together. Only correction. If you see one weak, then no reaction. Okay, so if you see Mg and Zn2 plus, Mg and Zn2 plus, Mg and Zn2 plus. So if you compare these two, okay, Mg, yeah, and Zn. Weak, strong, weak. Okay, so you see, they ask for Mg and Zn2 plus. So you can see clearly, Mg is strong reducing agent, Zn2 plus is strong oxidizing agent. So that's why in this case, yes, set 1 to have reaction. Yeah. So reaction occur. Okay, reaction occur. So because Mg is a stronger reducing agent compared to zinc, you can say either one. Okay, you can say like this, or you can say Mg atom release electron more easily and oxidation occur. You can say either one. Because you know answer scheme in SPM got more than one answer. Can be accepted. So like answer scheme can be many sometimes. Like this kind of question, you can have different way to explain your answer. Okay, so that's why you can see slash 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 all this. Okay, you can either say they are strong Ra, Mg is strong Ra, or you can say Mg can donate electron easily, and oxidation reaction occur. Meanwhile, same thing happened to Zn2 plus. You can say it's a stronger oxidizing agent. Okay, when zinc ion receive electron more easily, and reduction reaction occur. You can say either one. You can say Zn2 plus is strong OA, or Zn2 plus receive electron more easily and reduction occur. So the final you can sum up. Redox reaction occur between strong Ra and strong OA. That's it. Actually, the first part and the fourth part is quite the same. Reaction occur. So you count as 1 mark. But exam, they also tell you like, oh, you can write either one. Okay. Even because 6 marks, right? 6 marks means each set 3 marks. So it means if you forgot to write the fourth one, it's okay. Or if you forgot to write the third one, it's okay. So you still got 3 marks. But it's the best if you write everything. Okay. No worry. Okay. Just you can just choose one to write. Okay. Just choose one. The sentence they like. Okay. They're comfortable. And then P and what? P and Zn2 plus. P and Zn2 plus. Which one? Okay. So you arrange Zn, they only P. You see properly. Okay. We arrange Zn first. They only arrange the P. So the left side is OA, right side is RA, weak, strong, weak. Okay, so now you see they ask for P and Zn2 plus. Now you see they are strong or weak. So P, weak reducing agent, Zn2 plus, weak oxidizing agent. Do you think they got reaction? No, obviously. If you see weak, no reaction already. The moment you see weak, okay? Reduction cannot occur, oxidation cannot occur. Very difficult to donate electron, very difficult to receive electron. So weak agent and weak agent reaction does not occur. Okay, just like that. So yeah. Okay. Okay, so reaction does not occur. You can just say, where? You can either say copper is a weak reducing agent. You can say P, you can say copper, same thing. Okay, because just now you suggest P is copper, right? P is a weaker reducing agent. Or you can say a, am I right? I'm not Mg, sorry. I think the answer got it wrong. I'm so sorry. Here, okay, it's not Mg, sorry. P atom, you can say copper atom. Sorry, I supposed to type P atom or Cu atom. P or copper is more difficult to release electron. Oxidation does not occur. You say either one, You say weak agent or you say more difficult to release electron. But I suggest the second method. And then Zn2 plus is a weak oxidizing agent. Okay, or you can say Zn2 plus more difficult to receive electron. reduction does not occur. And then redox reaction does not occur between weak reducing agent and weak oxidizing agent. Okay. That we got two more questions. Okay. So redox reaction meaning. Try to write yourself first. Okay. And then first one settle, huh? The meaning, just now I talked about it already, huh? And that, I mean, chemistry, you have to write the whole meaning. If you miss one word, two word wrong, okay? So, you know, okay, then determine the reaction is redox or not, okay? So, explain your answer in terms of change in oxidation number, okay? So, in this case, now, reaction is redox or not? It means with the, I mean, in this case, not necessarily redox periodic reaction. Okay, not every reaction is redox. Okay, a lot of them are not redox. One of the example is neutralization. That is also not redox reaction. Okay, including this one. If you know what is it, okay, if you see properly, AgCl is an insoluble salt. Okay, so it's a white precipitate. Prepared insoluble salt is double decomposition reaction, or you call it as precipitation. Normally, precipitation is also not a redox reaction. Why? Because they ask you for oxidation number change, right? You have to explain for you. How do you explain? Now, very simple. Okay. So you check every oxidation number. How you check? Very simple. Based on the charge. Like you know, NaCl is Na plus Cl minus, right? So you know the oxidation number is positive one and negative one. So simple, right? So and then Ag, you know, Ag is 1 plus, positive 1. Oxygen is negative 2. Okay, you might ask what is N then? So how calculate? Calculate, it means Ag is positive 1. The total plug add together is 0 because outside no charge. Okay, plus N plus you got 3 oxygen. So 3 times negative 2 equals to 0. the whole thing, add together 0. Then you will get N punya oxidation number, negative 6. So you get negative 5. Move the other side, become positive 5. So you know N is positive 5. This is reactant before. After same thing. Sodium is positive 1, O is negative 2. So if you do the calculation, you get the same thing. N is positive 5. Ag positive 1, chlorine negative 1. So if you check for every element, if you check there is no changes. If you see properly. Sorry. Na before and after positive 1. Cl before and after positive 1. And negative 1. If you see no changes, if you see like Ag, same thing, positive 1. Nitrogen, the check okay, nitrogen, both are positive 5. O, same thing, negative 2. So if you see no changes, okay, you have to tell them this is not a redox reaction. Okay, not a redox reaction. Why? Because oxidation number for each element before and after unchanged. Before and after reaction, unchanged. Okay. Oxidation number for each before and after reaction, unchanged. One more sentence is you can literally pull up. You can say everything. Okay, you can say everything for every element. You can say, oh, oxidation number for Na before and after is positive 1, chlorine. Before and after is negative 1, okay, respectively. And you can say Ag, right? Ag, positive 1. You can say N, positive 5. You can say O, negative 2. Like that. So it's more like an extra question to do with you. That came out trial in other state before. Okay. Okay. So B. Iron is extracted from iron ore. Okay. Fe2O3 using coke. The production of iron industry is represented by the following chemical equation. So this equation, okay, we talk about it in normal class. Okay. You put the iron ore into the furnace, the blast furnace. Okay. So that the iron ore, okay, carbon can turn the iron ore become iron. Okay. So then you also, another one, you put limestone, right? Remember? You put three things. Iron ore, the hematite, okay, the coke and the limestone. Okay. But here they didn't tell you anything. They didn't ask you for specifics. They just asked you to find number of mole. Okay. So if the factory is able to process 800 kg iron ore by using excess carbon, calculate the mass of the iron form. Okay, so this is a simple question. Okay, so 800 kg of iron ore. Which one is iron ore? Iron ore is the Fe2O3. They tell you already. So 800 kg information right now. Mass of iron, this one. Fe, mass equals question mark. So same thing, 3 steps. Same thing, 3 steps. Okay, so yeah. First step, find number of mole. Because they give you kg, you know it's mass only, right? So you only use one formula, right? Number of mole equals to mass over mass. For the first and the third, same thing. Use the same formula. Okay? You just substitute different thing. Second step, you just do mole ratio. You know lah? Okay, so what should we do? Bilangan, in Malay is bilangan mole. Okay, in English is number of mole of Fe2O3. Okay, which can be mass over mass. The mass is 800 kg. But remember, the mass is gram. So you have to change kg to gram. You have to multiply 1000. So 800 multiply 1000. Molar mass is 2, Fe is 56. 3O is 3 times 16. Add together. Then you will get 5,000 more. 5,000 more. Second step, do ratio. Ratio Fe2O3 to Fe. So if you see it's 2 to 4, right? And right now, based on equation, the ratio is 2 mole of Fe2O3 will produce 4 mole of Fe. If your school teacher normally asks you that, just write sentence, you write produce. Okay. And then 5,000 mole means you have to multiply 2, right? You get 10,000 mole of Fe. Okay. And then you use the 1,000 to find the mass of. So the mass of Fe is, in Malay is GC, mass of Fe is, if you want to find mass, you use number of mole multiply molar mass. So number of mole is 10,000. Molar mass of Fe is 56. So you will get, I think you will get 560,000 gram. Am I right? Determine the oxidation number of iron in Fe2O3 and state the IUPAC nomenclature of the compound. It means the name, the proper name. Very simple this one. Okay. So 2 marks only. So they ask for iron, how much? So iron got 2 Fe plus. Remember, O punya is -2. So, but you got 3O here. So you use plus 3 times -2. Add together equals 0 because outside there's no charge. So you get 2 Fe equals to +6. Fe equals to +3. Okay. And the name is very simple. You know Fe is 3 plus. It's called iron 3 oxide. In Malay, it's ferrum 3 oxide. Okay. Okay, so C, okay, 2 sets of experiments are carried out to study the effect of other metals on rusting of iron. Okay, so for set 1, iron is coiled with metal P. Okay, so this one they ask 10 mark question. Okay, so and then set 2, the iron coiled with metal Q. So they also say iron dipped in hot jelly solution, also containing potassium hexacyanophthalate and phenolphthalein. So the moment you see, okay, why do you got hot jelly solution? It just so that you can see the color clearly later. Okay, what color? When you got these two then you get the color. Okay, because if you got potassium hexacyanoferrate 3, okay, in Malay it's called kalium hexacyanoferrate 3. Okay, this is to detect the presence of Fe2 plus. Okay, untuk mengasan ion kehadiran ion ferrum 2. Okay, so whether it exists or not, okay, how do they prove Fe2 plus exists? You will get the blue spot. You get blue spot. Okay, and then if you see phenolphthalein, they want to see whether OH minus presence or not. Because you know, right? You know phenolphthalein in neutral nitrogen, when you put inside alkali, you will get pink color. Means hydroxide for this, because you know, okay, if you got alkali, which is OH minus, you get pink color. Okay, so it means, you know, right? How do we get Fe plus? When the ion has rusted, the Fe rusted become Fe plus, then you know the ion has rusted. If you got blue spot coming up, okay, pink spot, then no rust. So obviously, they tell you the result, and they ask you to suggest the metal. Okay, suggest metal, and they ask you to explain 10 marks. Okay, I don't know they come out for this cell or electrolytic cell, or they come out this part. Okay, I don't know. Okay, or they come out both. I don't know. Okay, so pink color form. Okay, you know, pink color form. You already know lah. This means iron does not rust. Very simple. Okay, it means when they call it metal P can protect iron from rusting. So which one can protect iron from rusting? Based on the reactivity of metal. Alright, one time. Remember how to memorize this one. Kalau nak kawin mesti ada zinc flexible supaya perempuan hasil juga nak. Okay, so you know iron is here, and we normally don't use potassium, sodium, calcium. Okay, so the one they use is MgAlZn. These three. Wait. These three can protect iron from rusting. So you only got one mark. So P is what? You choose either one. Okay? You choose either one. Let's say I choose magnesium. Let's say I choose magnesium. Okay? Just any one. No need to write so many. Okay? Just choose one. Okay? And then the one that caused the iron rusting. Dark blue solution form. This one. Dark blue color form. You know that the iron has rusted. Okay? Because you got Fe2 plus for this. The top one is the OH minus for this. So it means metal Q cannot protect iron from rusting. Means we speed up the rusting of iron. Which one is speed up the rusting of iron? Either one. Either is tin, lead, copper, silver. Can. Out of this four metal can. But normally I recommend copper. Yes, I recommend magnesium. Okay. So only got 2 marks secure. If they ask only suggest, right? Suggest means you can write the name or write the formula. Accepted. But you have to include. Okay, explain why there's a difference. This one you explain. Difference in the observation. Okay. Include the answer with half equation for oxidation. Okay. And state the metal they are oxidized. Yes. Okay. So you have to explain which metal is oxidized. Okay. Which one will not rust. Okay. So for set one, the metal doesn't rust. I mean the iron doesn't rust. The P will get oxidized. Okay. Or you can say magnesium. Okay. So of course the most important word here is to compare which one is more electropositive. You know what's the word? What's the meaning of electropositive, right? Electropositive means the tendency to release electrons. Okay, for P is higher, P is higher. Okay, so P for those who is more electropositive means that you will get oxidized by releasing electrons to form Mg2 plus. Example lah. Okay. Number 5, if you forgot, right, it's okay. Okay. If you skip, it's okay. But just to add a point lah. At the point, oxygen dissolved in water, because I talked about how does the pink color form, right? So I add a point. Okay, I add a point. Pink color because of this ion. How do you get this ion? Based on this half equation. Okay, number 5, I show you. Remember, O2 dissolved in water, receive electron, become OH minus. Okay, you got 4 OH minus. Balancing 4H, so you multiply 2, electron multiply 4, because you got 4 negative. So you no need to write, okay, but just to explain to you lah. Okay, but sometimes they ask you to write, so you have to know this equation. Okay, number 5. This is what happened, number 5. Number 6, okay. Pink color shows the presence of OH minus. And the important point is, rusting of iron does not occur. Even if you forget to write the pink color one, it's okay. Yeah. But you should say rusting of iron does not occur. Then the half equation for NO they ask you, right? Half equation. So Mg become Mg2 plus. Even if you write P become P2 plus is correct. Okay, nothing wrong. Maybe I feel like either is this one. Okay. Either if it come an essay lah. Either is this one. Okay, rusting of iron, new, or the electrolytic cell or vertic cell. Either one. I feel like these two are more popular. YouTube one I would say is less. It might come out in like maybe like sometime maybe in structural question mark. I think so. Four seven can come out essay, can. Very possible. I tell you either the popular come out essay Form 4 chapter 6, Form 4 chapter 7, Form 5 chapter 1. Yeah. Form 4 chapter 5 sometime. These two, okay, sometime. Yeah. But in SPM record so far, right? SPM record these two never come out essay. So far. All in structure. Okay. Form 4 chapter 8 came out before. In SPM 2024. Came out in question 11. Form today is the one, the glass, ceramic, alloy, composite material. Yeah. Last year came out less. Not much. Last year came out a lot of this. Yeah, a lot of this. Yeah. Can I? And Form 5, Chapter 3. Yeah. If you learn already, okay. I think Form 5 Chapter 4 also come last year. The polymer one. But I'll teach you later. Okay. Okay, this one, set 2. Set 2. You say no? Now, metal Q is less electropositive than iron. So it means iron, you can say the body also can. You can say iron is more electropositive than metal Q also can. Then that's why iron is the one get oxidized to form Fe2 plus. Dark blue solution shows the presence of Fe2 plus. Rusting occur. The important point is rusting occurs. Rusting occurs. Then Fe arrow become Fe2 plus. Settle. Okay. So question 38. Okay. Diagram 11.1 shows the apparatus arrangement of the chemical cell. If you see chemical cell, if you see voltaic cell, galvanic cell, same thing only. Same thing. Okay. They are called as voltaic cell. So this one they use salt bridge. Okay. To split the magnesium and silver. Okay. I give you maybe 10 more seconds. Start. What is function of salt bridge? To complete the electric circuit by allowing the movement of ions. I explained it in the structural question YouTube video. So the more detailed one, you might not understand what it is. Okay, I explained very long in the YouTube. I think it's on question 20. I forgot which question. I explained it in question 23. The YouTube same thing at the YouTube one. You got sulfuric acid. This one also salt bridge. This one is also salt bridge. To complete electrical circuit by allowing the movement of ions. More details. What do you mean by allow the movement of ions? I explained in the YouTube video. So in a very long manner. Okay. Okay. So based on this, okay. Okay, so same thing lah. Okay. Magnesium and silver. So you got two different metal electrodes. This is voltaic cell. Voltaic cell. So Mg dissolved become Mg2 plus. Why? Okay. The more negative inert value is anode. The more positive inert value is cathode. So the electron flow from anode to cathode. Okay, it means Mg will donate electron, become Mg2 plus. Okay, by donate electron, become Mg2 plus. At silver, cathode positive. Yeah, cathode positive. Okay. Ag plus become Ag. Okay, this one undergo reduction by receiving an electron. Okay, so you know lah. Okay, it means again become thinner for anode, become thicker for cathode. You got gray solid deposited, same thing. Okay, so they ask for a energy change involved in this cell. Okay, voltaic cell means itself is a battery. Itself can produce electricity. So it's like the change is from chemical, literally, right? Literally here say it's a chemical cell. So from chemical energy to electrical energy. If it's electrolytic cell, terbalik. Okay. Which one is negative and positive terminal? Negative one is the anode, is the magnesium. The positive one is the copper. I mean the copper, sorry. Here is silver, sorry. Then the oxidation half equation, very simple. Okay, Mg become Mg2 plus by donating 2 electrons. Ionic equation, okay, you must have two half equation from anode and from cathode. Anode is Mg become Mg2 plus. Cathode is Ag1 plus, receive 1 electron become Ag. Don't forget so it's only one. Okay, be careful. So that's why in this case, you check the number of electron is not balanced. So this one is one, this one is two, right? So you multiply two for the half equation at cathode, and then everything is two, right? Now no need to write the electron. Okay, write the leftover lah. Leftover is Mg, left side Mg plus 2Ag plus arrow, Mg2 plus 2Ag. Okay. Voltage, okay, I mean, sorry, cell notation first. Cell notation. Okay, again, they didn't give the concentration, so you just write anode part first. Oh, Mg. I write the English one, Mg solid. The answer scheme I have to change a bit. I think I send tomorrow. Okay. I should edit a little bit because got many wrong. Yeah, so Mg2 plus Aq, Cu2 plus Aq, and no Cu. I like Cu so much. Okay, I love Cu so much, I don't know why. Okay, so Ag plus Aq and Ag solid. This is in Malay, and the voltage, the E naught cell, the voltage, cathode minus anode. That's it. So simple. But remember your answer, you should have positive. Show them positive. Must have the positive. Okay. When need to platinum? What do you mean need to platinum? Use, if you see carbon and platinum around the same thing. If you see carbon and platinum or platinum is around the same thing. They are not really involved in the reaction. But normally it's carbon because carbon easier to be found, right? Yes, some is right, some relation. Yeah, so because some cell, okay, if they come out like this, when you need, because when they come out like this, they put platinum here, and they put the direction they put is Cl minus to Cl2, let's say. So that's a bit of troublesome. Okay. So like put here, they change to Cl minus. That means because let's say your cell notation your beginning and your ending should have electrode. Okay. If let's say your Mg1 you change to Cl minus to Cl2, the Cl minus is not the electrode. So that's why you have to, in front, you have to put platinum solid first. Or sometimes it can be ending platinum solid. It means the closing and the opening, you should have electrode. Yeah. If you see platinum means, yeah, you have to use platinum. You have to put platinum as the answer. Yeah. But normally don't come out in our syllabus. Maybe in Form 6, yes. Okay. Okay, diagram 11.2 shows the apparatus setup of purification of copper metal. Trial got interesting. Okay. Interesting. I mean, I saw few question before, yes. Okay. It came out before, but a bit rare. But yes, okay. Just for you extra, yes. Ending must have platinum. If they use platinum. Because the moment they use platinum means uh the platinum doesn't involve in the reaction. Either it's like Cl minus become Cl2, Br minus become Br2, H plus become H2. This one at vortex happen. So you have to use what platinum. Okay. And then diagram 11.2 shows the apparatus setup of purification of copper metal. Okay, so you can see again you got two shells. Okay, two cells. And nice again. If you see copper and zinc, oh, you know this one you got two different metal electrodes. This is vortex cell. Cell Q is electrolytic cell. Both are copper. This one is the purification method. They want to make the impure copper clean, become pure copper. Okay, how? They will always connect this to anode. How do we know? You can check. Okay, so it means again, right? The E naught value given. So for vortex cell, you can already check between zinc and copper. So zinc E naught value more negative and not. Copper E naught value more positive, cathode. So you don't know, okay? And not negative, cathode positive. Electron flow from anode to cathode. So you can see okay? Pure copper is cathode. The other side means impure copper is anode. Electron same thing, flow the same way. Okay, then you analyze, you know Zn dissolve becomes Zn2 plus. Literally the same thing I talked about just now. Cu2 plus becomes Cu. Okay, I don't do waste time Okay, same thing. And then this one you analyze the electrolyte. Copper 2 sulfate solution, same thing. You got 4 ions. Cu2 plus, SO42 negative, H plus, OH minus. Cation goes to cathode, and ions go to anode. Same thing. Okay? Am I too fast? No, no. If you don't answer, you ask me. Okay? Just repeat around the same thing. Okay? And ion go to anode, cation go to cathode. Okay? And then you choose just now I already talked about it, right? Cu2 plus punya E naught more positive compared to H plus. That's why I choose Cu2 plus, undergo reduction, become Cu. Here a lot of copper found. And not based on the thing just now, I talked about it. Okay. The factor. Okay, I talked about it just now. I don't know where I did, but yeah, here. This part. So the same thing, Okay, the same thing. Okay. So the first factor, do you have copper or silver? Do you have copper or silver? Yes. Okay, if you see they're using copper, so the first factor, just follow the first factor lah. Okay, it means you don't choose these two ions. You choose copper to undergo oxidation, becomes Cu2 plus. Okay, so the question they ask is compare the observation on the color of electrolytes in cell P and cell Q. Now, what is the color of copper to sulfate? Because they ask for color of electrolytes in cell P and cell Q after 30 minutes. So both are using copper sulfate. Blue, right? So you know that if you see Cu2 plus, you know it's already is blue color. But they ask whether the blue color intensity decrease or increase. Okay. Now, for cell P, is it increase or decrease? The intensity of blue color. You look at cathode, then you tell me what happened. What ion causes to become blue? Cu2 plus. So now, based on this reaction, after 30 minutes, do you think the blue become less or more? Less, okay? Because all of the Cu plus now turn to Cu. So it means the Cu plus getting lesser and lesser. Okay? So you can say the blue color solution become paler. Or you can say intensity of blue color solution decreases. Same thing. How about cell Q? How about cell Q? Intensity of blue increases or decreases? No. The answer is no change. Okay. So look at this reaction properly. Yeah, electrolyte cell always no change one. Okay, because why? Especially like this. Okay, because if you see properly, yes, an anode produce a lot of Cu2 plus, but will be cancelled out by the action at cathode because the cathode will literally making the Cu2 plus become lesser. So one side become more, one side become lesser. So it's like +5 -5. So like it's like cancel out each other reaction. So it means the net zero. It means the blue color won't change. Okay, because one side trying to produce a lot of Cu plus, one side trying to reduce the amount of Cu plus. So it's like the same thing. Okay, I mean like the action will cancel each other. Yeah, cathode undergo reduction. Yes. Okay, one will form Cu plus, one the Cu plus will form Cu. One cycle. Okay, be careful. So it's like no change, remain unchanged. First point. Okay. Okay, you can choose one. Okay, you can choose one. You can choose either you can say become paler, or you can say intensity of blue color decreases. Okay. You either choose, you can either write CuS4, you can write copper sulfate, the name also can. You wish lah, your wish. Intensity of blue color of copper sulfate decreases. Okay. The other side means no change. No change. Remain unchanged. Intensity remain unchanged. You see a double slash means you write either one. You choose one to write. Okay. You choose one to write. It's told you just now, right? Answer scheme can be many questions. Can be many answers. Reason they ask you to explain, right? Explain. So you have to say the keyword is concentration of this ion. Of these ion. Okay, so concentration of Cu2 plus, one side remain unchanged, the other side decreases. Okay. They talk about, okay, copper to ion, one side is, okay, it means a cell, I don't know which cell already, cell P lah, cell P, the vortex cell, okay, the Cu2 plus discharge to form copper atom. The other side, the other side is a bit complicated because two sides, right? The red and the red cancel each other. Okay, the rate of copper 2 ion discharged to copper atom at cathode, okay, is equal, okay, the keyword is here, is equal, okay, to the rate of copper atom ionized to form Cu2 plus at anode. There you go, 6 marks. Okay, you can copy first. Okay, then you go to the last question. Then you finish. Okay. Okay, so C, diagram 11.3 shows the list of materials and apparatus provided to construct a product cell. Okay, so you got tomato, conducting wire, LED bulb, iron nail, zinc strip, copper strip, plastic spoon, magnesium strip, carbon rod, and sandpaper. So they give you 10 things. Okay, then they show the induct value. Okay, that the material based on the material given. Okay, then okay, so by using your chemistry knowledge, okay, I think I haven't updated. So I think the updated version, I think I type more lah, okay, because this one I type less already, okay. I think your version, okay, they show the sentence more, okay. So sorry, describe briefly the steps. I think inside your new one got steps of constructing the voidic cell and explain the redox reaction. And that take this. Okay, then determine the value of the voltage reading obtained. It must. Okay. Yes. So this one can come out in essay question 11. Okay. Can you manage question? Okay. I don't know. Okay. But this one of them. Okay. So this one you have to construct and voltage cell. Okay. So, but they give you tomato. Whether they give you tomato or orange or whatever. Okay. Yes, it can work. Okay. So let's say pair with. Okay. First, they ask you to do they ask you to draw the diagram. Yeah. They ask you to draw the diagram. Okay. Draw the apparatus setup of vortex cell. They can light up the LED bulb. Okay. So I use this tool. The material I use is I use magnesium strip. Of course, you can use zinc strip. Okay. Also can. Then I use copper strip. Okay. Because they didn't give you any electrolyte. Normally, you put this, right? Electrolyte, you put copper 2 sulfate, but they didn't give you anything, right? They didn't give you anything like this. So what you do is, you take this you take this two electrode, then you chup inside the tomato lah. Then you chup inside, then you connect the wire. Okay? Connecting wire, then you connect the LED bulb. Yeah. So this diagram for 2 marks with labeling. Look something like this. It means your tomato is your electrolyte. I saw this question like a few times. So a little bit interesting. Drawing 2 marks and then okay, they ask you to uh, draw a vortex cell, but no electrolyte. So you use tomato as your electrolyte. Okay. Then again, these two you can rub with sandpaper. It's around the same set. Okay. Rub magnesium strip and copper strip using sandpaper. 1 mark. Because if you put too long, right, then it exposed to air. Then a bit dirtier. So you have to use sandpaper to rub off the oxide layer. Then you say, you say connect. You connect to the connecting wire. Okay. Connect the magnesium strip and copper strip, okay, to the LED bulb using connecting wire. You just explain how you do it. That's why you see, if you see like describe the steps. You already know have to write this up. Okay. Can be in paper 2 many times. Okay. Question 11. But I don't know which question, but number 4 and number 5. Okay. You insert these two into the tomato. Then you explain the reaction, because they also ask you, right? They also ask you, explain the redox reaction take place. That will give you 2 more marks. Because you know, one is oxidation, one is reduction, right? The procedure for 3 marks, drawing 2 marks, procedure 3 marks, drawing 2 marks, describe 3 marks. Okay. Then the explaining the redox reaction take place, 2 marks. Calculate the value of voltage, 1 mark. So you got 8 marks. Okay. So number 6, which one undergo oxidation? See, you got magnesium and copper, right? Which one undergo oxidation? Obviously, one side is anode, one side is cathode, is it? So it means here, magnesium undergo oxidation become Mg2 plus. Uh, magnesium atom undergoes oxidation become Mg2 plus. Okay? Which one undergo reduction? I mean, what turn to what? You don't start with copper, isn't it? You don't start with copper, isn't it? You start with what ion? Now, let me ask one question. In this tomato, do you have Cu2 plus? Inside a tomato, do you have copper ion? No. So, how? But inside tomato got what? What do you think? Fiber. uh, Other than that, I mean, try to relate to chemistry. What ion do you have? What do you think? Isn't it inside is watery? Obviously, got water. Yeah, got water. Got water, then got what ion? Got what ion? Yes. So same thing, is it? The anion go to anode, the cation go to cathode. It means now you don't have copper ion. So which ion undergo reduction? H plus. Okay. So H plus you become hydrogen gas. Yeah. So many students cheat by this one. Okay. So the number 7, the answer should be hydrogen ion undergoes reduction, receiving electron to form hydrogen gas. Yes. Remember, okay. Sometimes you have to think outside the box. Okay. This is one of them. What do you very dog? Huh? What's the matter? This is a bit logical. Okay. I know normally you have seen, oh, like this, inside the copper 2 ion become copper. Oh, but here they use tomato. That's a difference. So it means for the inert cell, right? For the inert cell, for the inert cell, you don't use the copper one. You use between the Mg and the H plus. So you use this to minus this. So you use the hydrogen one, positive 0.00 volt minus negative 2.38. So you get positive 2.38 volts. Ah, interesting, eh? Okay, so thank you for coming. See you again next week. Any question? No question? I see you again next week. Okay. I mean, for no other class. Okay. See you again. You copy or finish? Okay, see you again.